May I call upon next speaker, Mr. Dr. S.V. Taralkar. He is associate professor in chemical engineering at Maharashtra Institute of Technology, Anandi, in Pune. He is going to make presentation on material and energy balance calculations to enhance the profitability of sugar industry. His brief resume is, please be seated. Dr. Suyog Kumar Taralkar is an associate professor in chemical engineering and dean of quality assurance at MIT Academy of Engineering, Anandi, Pune. He has been an honorary chairman of the Indian Institute of Chemical Engineering, Pune Regional Center from 23 onwards. He served as honorary secretary of ISCG for 2 years. He completed PhD. He completed his chemical engineering in 2001, MTech in 2005, and PhD in 2011. His research deals with first process development for extraction of active ingredients from medicinal plants. Second, preparation, characterization, and performance evaluation of polymeric ultrafiltration membranes. And third, modeling and simulation of chemical processes. He is a reviewer of the editorial board of several international peer-reviewed journals. He has handled various research and consultancy projects worth rupees 57.5 lakhs funded by the university, CRB, Department of Science and Technology, Government of India, and industries. I request the speaker to start his presentation.
Once again, request. We will have to complete this in 25 minutes with question and answers. So Mr. Taralkar, please note this.
Yeah, definitely I will finish within time.
Thank you.
All the dignitaries of the dais on the dais and the delegates which are present over here for the one-day seminar organized by DSTA. So the topic which is selected for this seminar is the heat and mass balance in sugar and allied industries. Basically, as a chemical engineering teacher, I have considered the basics and how we can implement that particular basics in development of this particular sugar and allied industries, mass and energy balance. So my topic is covering the material and energy balance calculations to enhance the profitability of the sugar plant. Slide changer. Please go to next page. Yeah. So basically, if we consider the material balance is nothing but it's a law of conservation of mass, and we know law of conservation of mass can be applicable for the reacting and non-reacting systems. And there is a need of material balance calculations, because whenever we are working in the plant, we may do this particular material balance or the energy balance calculations periodically, but there is a need, as Alok Pandit sir has mentioned, if we have digital data with us, definitely we will be able to go for the simulation or the digital twin. And the similar type of example I am going to show from one of the research paper. So either we can do this yearly, monthly, weekly or daily, but if we are doing daily, then definitely it will be helpful for us to enhance the profitability of the plant. What are the main objectives of this particular material balance calculations is mainly to improve the efficiency of the plant. Second is to maintain the production rate. Third one is to reduce the environmental damage. And fourth one is to maintain or control the process in that particular plant, the different processes which are involved in that particular plant. So by considering this, hello, thoda sa over geta. Yes. Now don't change the setting, so that I will change. So basically, why we need to study the material balance calculations? I have given one particular example, that is the separator. If we have a separator, there is a feed, and that feed is a mixture of different components, and with that particular separator we will be able to separate out these components with stream 1 and stream 2. So by considering that, these particular calculations will be the prerequisite for other processes, because after that it will be followed by certain other operations. So we should have that particular calculations ready, and understanding the problems which are involved in that particular process or the plant. is also the basic requirement of the material balance. And third one is the transfer material balance skill to the another balance, maybe the energy balance, because energy balance also depends upon the material balance calculations. The very good example which is also given by Himmelblue in his book, that is the basic calculations of the this particular chemical processes. So he has given the example of our bank statement, and we can see whenever we are taking our bank statement, so we are getting some deposits into that, the withdrawals from that particular bank account. We are also getting the interest on that particular deposits or the balance which we are having, and generally at the beginning of the year we are having the opening balance, and at the end of the year we are having the closing balance. If we just consider all these parameters, then the initial condition will be considered as an opening balance at the start of the year, and the final condition is considered as a closing balance of that account. Whatever the deposits and the interest which are there is the input for that particular process or that particular system, and the outputs are nothing but the withdrawals from the account. So in that particular scientific way or the material balance calculations way, or we can consider the law of conservation of mass, then this closing balance minus opening balance is equals to sum of all deposits and the interest, that is the input, minus output, that is the sum of all withdrawals. And the difference between this closing balance and the opening balance is nothing but the accumulation. And many of the times the accumulation is generally neglected. We generally consider whatever the inputs are there and whatever the outputs are there. If it is not matching, we are saying something is wrong in that. But whether it is accumulated within that particular system or not, that need to be also understand. The material balance are generally done for, as I mentioned at the beginning, it will be done for the physical systems as well as reacting systems. When there is a physical or reacting systems, the process will be considered as a steady state or unsteady state. So in case of steady state, we know that parameters are constant with respect to time, but in a real life, in a real plant, the parameters are changing with respect to time. So therefore we need to consider the unsteady state system where the accumulation comes in picture. So when we consider these particular systems, a simple example of the storage tank again, if the input and output parameters are constant or the same, or input is equals to output, then there we call it as a no accumulation is there, but the input and output is not matching with each other, we are saying that there is accumulation. And what type of accumulation is there? Either it is positive accumulation or the negative accumulation. So in case of positive accumulation, the material is getting accumulated within the system, whereas in negative accumulation, material is taken out from the system with a higher rate. This law of conservation of mass is the basis or the principle for writing this particular material balance, and we need to consider all these parameters, all these terms which are there with that particular system, so that we can consider the material input to the system minus material out from the system plus material generated within the system if there is a chemical reaction, and minus material consumption within the system if there is chemical reaction, that means the reactants which are consuming, is equals to time rate of change of material within the system, that is nothing but the accumulation. In case of non-reacting system, the generation term and the accumulation term will be neglected, so that we will be having material in minus material out is equals to accumulation. And again, for a simplicity, generally the material balance is generally done with the simplicity that accumulation is 0, whatever in equals to out will be considering, then that input will be equals to output, that will be steady state, which is the ideal condition, not a real condition. When we consider this particular basis or the principle, there are certain steps that we need to follow to do this particular material balance calculations. First of all, we need to consider the block diagram of the system or the process, and with the help of block diagram, we are coming to know that what are the input parameters and what are the output parameters. After that block diagram, we need to consider the quantities of input and output streams. Then we need to consider the key component which is involved in that particular system. So in our case, suppose it is the sugar industry, we consider the concentration of that particular sugar within that particular juice and the output product. Then we need to select the basis. Basis is generally considered as the flow rate, either the inlet flow rate or the outlet flow rate. Then we need to develop the equations. The equations will be developed based on the overall material balance and the component balance of that particular system. And then we need to solve that equations with the different numerical techniques. So after solving that, we will come to know that whether there is a input and output parameters are matching with each other. Most of the cases, to adjust the concentration of the output or the product, this particular operation is generally done, okay, but it is not shown in that particular entire our PFD or the PNID. So that is the bypass, right? And this particular bypass operation is to just adjust the final concentration of the product. Similarly, there are another two operations, that is the recycle and purge. The recycle is mainly used to recycle back the unreacted or the unconverted material back to the mainstream, that is the input. But the purge is very, very important, and generally we skip this particular operation purge. The purge is used to remove the accumulated inerts. There are certain materials which are not taking part in the process, so we need to remove that particular material frequently or the continuously, so that there will not be any accumulation of that particular material within the system, which is actually overloading the entire process in terms of energy requirement and material requirement also. I will skip this particular chemical reactions. These are the basic things, that is the stoichiometry we need to check. The limiting reactant we need to decide. The excess reactant also we need to decide. Okay, based on that we'll be able to get what is the conversion, what is the yield, and what is the percent excess of that particular components. Now we'll move to the energy balance. Basically, the energy balance is generally done to reduce the cost of the operation. So this particular energy balance is basically depends upon the material balance calculations. So how much material we are supplying and how much heat is associated with that material, how much heat is utilized within the system, okay, and how much heat is coming out along with the product, that need to be calculated, and we need to do the balance. If we do that particular balance, definitely we will be able to reduce the energy cost of that particular entire process or the plant, and to provide the clean energy economically. That is also the another objective of energy balance. The third objective is identify the most economical source of fuel, because based on the calorific value in mainly in the sugar industry, we are using that particular bagasse as a source of fuel, but we need to also check the calorific value of that particular fuel and the utilization of the waste heat. In almost all unit operations, this particular thing need to be also considered, because whenever there is an input energy and something is coming out, whether there is any loss of that particular heat need to be also checked, and there are various techniques to minimize that particular loss of the loss of the heat, and that is considered as a waste heat that can be also utilized and recycled back to the entire process. When we do this particular material balance, again the law of conservation of energy is the basic principle for doing the energy balance calculations, which is also governed by the first law of thermodynamics, where we consider that the energy can neither be created nor be destroyed, but it can convert from one form to another form. So by considering that, we need to consider the energy input, that is equals to energy output plus the losses which are there within that particular system. So here the different types of energies are generally considered, but in the actual process plant we consider the heat energy, that is the important energy source that we are considering for this. When we do the energy balance calculations, there are basically two things that need to be considered. When there is only temperature change is there, no phase change is there, we consider it as a sensible heat change. And when there is a phase change but no temperature change is there, we consider it as a latent heat change. So whenever we are doing these energy balance calculations, these particular concepts need to be also considered. Otherwise, what we generally do, we generally consider the temperature change, okay, and based on that temperature change, how much is the energy requirement that we are calculating. During the chemical reaction, mainly there are three types of energy changes or the heat changes are there, or which are observed, that is the heat of combustion, heat of formation, and heat of reaction. So if we know the heat of formation and the heat of combustion, that particular data, definitely will be able to calculate heat of reaction for that entire process. And suppose we have this particular reaction, AA plus BB gives CC plus DD. If any reaction is happening in that particular process, then if we have a heat of formation data, then heat of reaction can be calculated by this formula, that is summation of delta HF for the product minus summation of delta HF for the reactant. And if we have heat of combustion data, then it will be exactly reverse, that is the summation of delta HC for the reactants minus delta HC for the products. And based on that, we will be able to calculate the total heat energy or the heat which is required for the entire reaction. I have considered one case study from the paper which is presented by this Starzak and the Davis. So they consider the South African sugar milling process, and that particular South African sugar milling process, whatever the data which was generated by that sugar mill, okay, is considered for that, and they have used MATLAB and this Sugar S as a software for comparing the mass and energy balance calculations. At the same time, they also consider the sugar ethanol cogeneration biorefinery also. So in most of the cases, the sugar industry is also having the distillery and the biorefinery also. So by considering that, this will be the actual, you can say, the flow diagram. So it is the sugar mill, then we are having the ethanol plant, and then the cogeneration also, where the biomass which is generated from the sugar mill is used, and the molasses and the drop juice can be also used for the production of this particular ethanol. This cogeneration plant can be utilized, can be used for generation of the steam, and that can be used for the ethanol plant or the distillery. So while doing the material balance, the step by step material balance is done. Initially they have done the material balance for the extraction. 0 means the starting position. After the extraction, the material balance is done for the clarification. After clarification, the evaporation of that particular, mainly the water, is taking place. So the material balance for the evaporation is done, and then crystallization, where we are getting the sugar crystals, and then different utilities are also considered for doing the material balance. At the same time, the energy balance is also done in this particular sequence only, so that will be able to compare whatever the results which we are obtaining with the MATLAB as well as Sugar S software. The equations which are used for the different unit operations like mixer, separator, distributor, reactors, whatever there in that particular process, they have considered this summation of all input parameters or the flow rates and minus summation of that particular output parameters or the flow rates, that is equals to 0. So again here accumulation is not considered. As I initially told, very simple step is neglecting the accumulation, but that is not the real case. So in all the cases, they have considered this particular flow rates as well as heats or the enthalpies which are associated with that particular streams. And based on that, these are the results which are obtained from the MATLAB and Sugar S. Almost in all the cases, the flow rates, temperature, purity, and the crystals, almost in all the cases, the results are exactly matching with each other. So it indicates that whatever the output parameters they have considered, whatever the input parameters they have considered, okay, without loss, it is matching with both the softwares. Okay, so MATLAB is also providing different libraries. Even though if we are not doing the programming, there are different libraries which are available. We can use that particular libraries for doing our simulation. That is the digital twin. And the Sugar S is the very specific software which is developed for the sugar industries mainly. And mainly in these particular countries, they are using this Sugar S for regularly calculating the material balance and the energy balance for the entire plant. Based on that, I have certain, actually this was, I consider this in the PPT so that question will be displayed first and after that answer. Okay, so it is the PDF, so all answers are also displayed over there. So material balance basically depends upon law of conservation of mass. Then the objective of the material balance is mainly to improve the efficiency. Then the difference in opening balance and the closing balance is nothing but the accumulation. And in case of steady state process, we consider accumulation is 0, which is the ideal case, and that is the beginning of all the simulation and the digital twin calculations. And the purge operation prevents accumulation of the inerts, and the energy balance supports to reduce the energy cost, provides clean energy economically, identify the most economical source of the fuel, and utilization of the waste heat. So these are the things from my side. So I thought I will cover the basics of this particular energy and material balance calculations, because all other speakers, they have considered the higher end of this material and energy balance, how we can implement in the industry. But how to do the energy and material balance is very important thing before going for any software, because that is the black box for us. What we are providing, that we should know, and what we are getting, that also we should know. Thank you.
This is truly the lead paper in concurrence with the today's topic, heat balance and mass balance. Very nice presentation.
interesting presentation theoretically for chemical engineering point of view. My request to you that considering all these parameters or software, if we are to use in our sugar industry, what will be the limitations?
As I mentioned, the softwares are the black box, and the black box are nothing but we don't know what is happening in that particular thing.
For
So
any software, whatever data you are giving,
correct.
how accurate that the data is, and can we get that kind of accurate data in our presently operating system? Is it possible?
Yeah, if it is the automatic plant, okay, and the digital instruments are already used, then definitely we'll be able to get that particular data. Suppose temperature, all temperature indicators, pressure indicators, flow rates, okay, if we get that particular data, definitely we'll be able to use these particular softwares. But getting data, whatever point that you have mentioned, okay, that is the very important aspect.
That's what I say. You know, I mean,
Yeah,
is it better to
that is instrumentation. Instrumentation plays important role.
better to utilize this kind of software in an actual plant? I mean,
Yeah,
why can't we do that kind of exercise? You see, I mean,
right.
I don't know. I mean, I'm not working in sugar industry, but normally the accuracy of the data what we get in sugar industry depends upon the sensors,
Right.
the temperature or whatever. For example, if you see today people are using sulfitation process. We don't have the sensor for that. We don't know how much it is going. We know how much it is going.
Yeah, it depends upon the accuracy of the instruments.
That's what I say earlier. So that's what I am asking. That what are the limitations of this kind of software using, data for sugar industry and to
See, the input is data.
material balance and energy balance.
Right.
Which is so I don't know how far we are there from that.
Input is data, and if we don't have accurate data, then
So that's what I am saying. That first of all we need to find out what are our limitations and try to overcome those limitations right from the nil.
okay.
For example, I am saying that 5,000 is it exactly 5,000 TCD or it is less or it's more? How accurate?
I don't know. In the industry, people only tell
That's what I think. Everybody
those who are
needs to
actually
know
working in the sugar industry.
Yeah, we need to that and we
Yeah.
need that kind of presentations here.
No, the validation of data is important.
Yeah.
The thing is that presently none of the sugar factories which are working
That's what.
and the cost of digitalization or instrumentation is comparatively very high to promote. I mean, looking to the economics of the financial conditions of the sugar factory, they are reluctant to invest in such a sophisticated system where naturally if invested today, tomorrow it will be beneficial. But even today, whether they can invest it or not is itself a problem.
The law is that garbage in, garbage out.
Correct.
So if you put in garbage, you will get output in
Garbage only.
Reluctancy of the sugar factories on this subject is only because of the final price of the sugar.
Yes, sir.
Economics, no, I mean you are talking about economics of the factory.
Sir, I want to make only one point. This discussion is very similar to the discussion we have in all the industries. Sugar industry is no exception. All industries have the same challenges as far as data is concerned. Every industry feels that automation is very costly, no point in doing, my engineers will not be able to use it. If they are able to use it, they will leave my company very fast, and so on. Right? So there is nothing different in this. Right? But at the same time, all industries have taken the courage to adopt the technology. So somewhere one has to take a leap of faith that this is a technology which is emerging. I mean, this is not a technology for today, right? We have been using simulation and all these tools for last 35 years. At least I have been using for last 35 years. So it is not something immature that it has come out of from lab, yesterday, right? So I believe sugar industry is ready to use these softwares. I will not agree with anybody sitting here. I can argue with all of you there. If someone says that my company is not ready for this tool, I will argue with him. I believe all of you are ready, all the industry is ready. Thank you.
No,
Not only that, I will add that people are benefited by investment.
See, there are industries in sugar industry also. There are lot many groups, private, especially private groups. They have gone wholeheartedly about this instrumentation and registration. They have got results. That's what I said. What are the prerequisites? Prerequisites are being done. Transformation is going on. It will take some time. It doesn't matter, but it will be.
Okay, one minute. Speaker has mentioned the applicability of the first law of thermodynamics in heat balance. Okay, I would like to add up to that. The entropy of the second law of thermodynamics has also got the direct and indirect bearing of the heat balance.
Okay.
I would like to request chairman to felicitate the speaker.
Can I answer these all things, because I have seen sugar factory using simulation worldwide. It's only the Indian sugar factories are much behind to use this simulation. As he puts Metal Lab, I'm personally using Metal Lab for simulation for estimation of the torque and wheel performance. Okay. So my observation is we have all the digital data available. Okay. Most of the factories has temperature, pressure, bricks, many things are digitally placed. Where we are lacking is the static modules of the simulation are not converted into the dynamics module. Why we need a dynamics simulation? Because our throughputs are not similar. It's not the chemical factory where the things are constant. Our inputs are dynamic. So we need a dynamic simulation model, not the static simulation model. Excel spreadsheet we are working since many years. Why Excel sheets we cannot implement? Because they are static. It cannot be dynamic. It cannot give and correlate with the real-time data. So what we need as a sugar industry in India is to develop our own dynamic simulation model that can be helpful for sugar industry. And I have seen in many industries, they are crushing on the same mill, highest performance with lowest power. Why? Because they are simulating very well the dynamics. Okay, that I feel. But data is available. Most of the factory we have digitized. Which factory won't have flow meters? All the factory has flow meter. Everything is available. Only we are not compiling it, not dynamiting it. Am I correct?
Yeah.
Thank you.
This is a very valid point. Yeah, Mr. Bukhari.
Last question.
Mr. Bukhari, I think the people should not have an impression that we are talking about the future. This technology is not implemented. I think that is a misleading statement. There are plants which are already working on this philosophy and they are being benefited. If somebody wants, I can quote.
I am the
give the
example.
names. Yeah.
I am the example.
Yeah, you are the best example. We also has set up one plant which is really working on the same philosophy, and they are benefited because the heat and mass balance which was considered at the time of design, how it is performing when it is actually working, it is compared and then it is told that your plant or your process is at this stage. Whether we are lagging behind by 5% or you have proceeded 2%. So that is already there. So whatever we are talking is not a future image. It's already in existence. Thank you.
Thank you very much.
Nice passing remark by Mr. Bukhari. Please felicitate the speaker.
Thank you, sir.